Hello and welcome to the video Scientific Notation. Scientific notation is a way to express very large or very small numbers and simplify calculations with them. Below are the steps, but we'll illustrate them as we go throughout our problem so you can see what each step means and what you need to know. So let's get started. Our first example, we want to turn this standard notation of 24,900 into a scientific notation. So the first step says to put the box behind the first non-zero digit. Look at the number 24,900. The first number that we saw was 2, which was a non-zero digit. So we need to put our box behind that first non-zero digit. So we'll take our box and we'll put it there. Now, the second step says to count from the box to the decimal. Remember the positive and negative directions when counting. But when we look at this number, you might not see the decimal. So if you don't see a decimal, then you have to remember that it's hiding, and it's always hiding behind the last digit. So we'll go ahead and mark it so that we'll know where it is. So now we must count from the box to the decimal. Note we're going in a positive direction. So positive 1, positive 2, positive 3, positive 4. So let's write our answer in the scientific notation. First we'll start with our number, and the box being where our decimal is. So 2.49. Now we follow it by the notation times 10. And the exponent is going to be how many times you counted from the box to the decimal. In this case, positive 4. So our answer is 2.49 times 10 to the positive 4. Let's look at some additional examples. So, first rule, or first step, put the box behind the first non-zero digit. So let's just look at our number and make sure that we're going behind the first non-zero digit. So when we start looking at our number, the first non-zero digit that we saw was 1. So we need to put our box behind that number. There we go. And now we have to find our decimal because we have to count from our box to the decimal. Now, do you see your decimal? So if you don't see your decimal, it's hiding behind the last digit. So that is behind the last 0 there. So we'll go ahead and mark it and make it visible. And now we need to count from our box to our decimal. We're going to go in a positive direction, so positive 1, positive 2, positive 3, positive 4, positive 5. So this answer will be 1.25. Scientific notation times 10 to the positive 5. All right, let's look at our last example. Let's find our first non-zero digit. So when we look at the number, when we start looking at the number, the first non-zero digit we saw was 5. So our box needs to go behind that 5. And now we need to count from the box to our decimal. Well, do you see a decimal? Yes. The decimal is right there. So we need to count from our box to that decimal. So we're going to go in a negative direction because this is going to the left. So this is negative 1, negative 2, negative 3, negative 4. So we write our number 5.28 times 10 to the negative 4. And that's our scientific notation answer. Now, what if we had these scientific notation answers, but we wanted to go back to the standard notation? Well, remember, your exponent tells you how to move the decimal. So if you want the standard notation, you have to move this decimal in the positive 4 direction. So let's take the 2.49 and let's move it in the positive 4 direction. So that's 1, 2, 3, 4. So now our decimal is there, but we have blank place values here. So we're going to put in placeholders. And there you have it, 24,900. So let's try that again. Remember, to get our standard notation from a scientific notation, just follow the rules of the exponent. So in this example, it's telling us to move our exponent in a positive 5 direction. So we're going to take 1.25 and do just that. Positive 5 direction. Positive 1, positive 2, positive 3, positive 4, positive 5. And we have blank place values here, so we'll fill them in with placeholders. 1, 2, 3. So there we have it. We got the standard notation back of 125,000. And lastly, this tells us to move our decimal in a negative 4 direction. So we're going to write our number and do just that. So 5.28, and we're going to move in a negative 4 direction. Negative 1, negative 2, negative 3, negative 4. And again, blank place values call for blank for 0 placeholders. 1, 2, 3. And there we have it, our original number, 0.000528. I hope you put this to good use. Thank you for watching. And as always, math is making amazing thoughts happen.